Hello everybody, so welcome to this channel. So this is the Math Daily channel, so whereby you learn math every single day, snippets from mathematics every single day. So this is going to be differential calculus series. We are going to start with differential calculus series. So for every concept in mathematics, there are always two parts to it: the conceptual part and the procedural part. The conceptual part is all about what is the meaning of that topic itself: logarithm, trigonometry. What does it mean? How do we apply it? So those are the conceptual parts. So and there's always the procedural part, that is the techniques, steps by steps process in which we use to solve. I'm not going to be dealing with the conceptual part in this particular series, differential calculus. I'm not going to be talking about Isaac Newton or Gottfried Leibniz or whatever. So we are just going to be dealing with the differential calculus techniques, how we differentiate functions from algebraic functions to trigonometric functions to logarithm functions. So that's what we're going to deal with. And in this particular class, today's class, we are going to be dealing with number one, differentiation of constants; number two, algebraic function; number three, differentiation of sum. So let's get into the tutorial. Welcome to this class. So we are going to start with, this is differential calculus. So then in this particular class video, we're going to do three things: differentiation of constants. So then we'll deal with algebraic function. So then we'll talk about differentiation of sum. So differentiation of constants, algebraic function, and differentiation of sum. So from what we have here, look at this. We'll start from differentiation of constants. So if you are very new to differential calculus, if we have y, so then that y that x is what we use as a notation for differentiation. So we say derivative of y is that y that x. So that y that x is used as the notation for derivatives. So notation for derivatives. So that means we are differentiating y with respect to x. So if you have u and u is a function of x, we say du dx, which is the notation for derivative of what? Of u. So just like that, u, even if you have v and v is a function of x, we write v like this, that v is a function of x, then we use the v dx as the notation for the derivative of v. So we'll be using all these notations a lot in this class. So now, what is derivative of constants? So when you have two functions, when you have a function of x, let's say y is equals to x plus 3. So y equals to x plus 3. So here now, x is a variable, 3 is a constant, x is a variable, 3 is a constant. So that is once it doesn't have the variable x, then it's a constant. Y also is a variable, so we call the y the dependent variable. And the x is independent variable. So the meaning of this is that y depends on x. So whatever the value of y is going to be, it is determined by x. If x is equal to 2, then y is equal to 2 plus 3. That means y will be 5. That's why we call it dependent variable. If x is equal to 3, that means y will be equal to 3 plus 3. That means y will be equal to what? 6. That's why we call y the dependent variable. It depends on this, and x the independent variable. So I hope you are getting that. Okay, so now derivative of constant. So it means, now I've just explained to you what we mean by constant now. So if you have a function like y is equal to 4 or y is equal to 6, then I ask you find the y dx. So we used to say that if y is equal to c, where c is a constant, if y is equal to c, where c is a constant, then the y dx is equals to 0. The y dx is equals to 0. If c is any constant, whatever the value of c, if c is 6, 7, 8, 10, 100, 1 million, derivative of c with respect to x is 0. Derivative of c with respect to x is 0. Why? Because derivative means the rate of change. The meaning of this is that if y is a constant, let's say y equals 3. If you draw the graph of this, y is equal to 3, and this is y-axis, this is x-axis, this is where y is equal to 3. Y is equal to 3. This equation that you have is going to be a straight line. That means there is no any rate of change. There's no any rate of change, so it's on the same value. So y is the same thing here when the value of x is 2. Y is the same thing when the value of x is 5. So that means there's no any rate of change. That's why we said the y dx is equal to what? 0. So if it's a variable, the graph is going to be something curved like this. So you can see that when x is maybe 1 here and x is maybe 3 here, so the value of y is going to be different. If you trace them, the value of y is going to be different. Then you can have the rate of change. So that's why we say derivative of constant, any constant at all, is equal to 0, because there's no any rate of change when your function is just a constant. Just from the name alone, it's constant. So derivative of constant is equal to 0. So that's the first thing you have to learn. Derivative of constant, you can write d dx of c, where c is a constant, is equal to 0. Constant of any number. So if they ask you to differentiate y is equal to 4, so that means if y is equal to 4, so that implies that dy dx is equal to what? 0. So the same thing with if y is equal to 6, so that implies that dy dx is equal to 0. So derivative of constant is equal to 0. That's the first one. Differentiation of constant is equals to 0. So that is that about that. So that is differentiation of constant. So then we move to algebraic function. I hope you've gotten this. Algebraic function. Algebraic function. So algebraic function is always something like this. Algebraic function. Algebraic function. So algebraic function is let's say if y, so y is equals to, we used to have it in form of like ax raised to the power n plus bx raised to the power n minus 1 plus like that. That's algebraic function. So the kind of function like this is the function where you have y is equals to x raised to the power n. It's still algebraic. So now if y is equals to x raised to the power n, if y is equals to x raised to the power n, then the y dx is equals to n, you bring this on here, x raised to the power n minus 1. N x raised to the power n minus 1. The meaning of this is that if y is equals to x squared, if y is equals to x squared, then the y dx will be equals to, bring this here to x raised to the power 2 minus 1. So that means that is equals to 2 minus 1, that's what? 1, 2x. So that means if y is equals to x squared, the y dx is equals to what? 2x. You get that? If y is equals to x squared, the y dx is equals to 2x. So let's differentiate another function. So what if y equals to x raised to the power 3? So then dy dx is equals to what? You bring this 3 here, 3 x raised to the power 3 minus 1. So implies the y dx is equals to what? 3x squared. 3x squared. Got it? So the y dx equals to what? 3x squared. 3x squared. Okay, so let's solve another example. Solve another example. So we'll solve this example on y 2x raised to the power 5. So we have 1 over 2x squared. So find the derivative. find the derivative. Find the derivative. So if y, so to find the derivative of 2x raised to the power 5, let's say y equals to 2x raised to the power 5. So how are you going to differentiate this? So by using the algebraic rule, where we know that ddx of x raised to the power n equals to n x raised to the power n minus 1. From here now, the y dx is equals to, you remember this is a constant, it's separate. This is the only thing that we want to differentiate. You got it? So differentiate this, that means you bring this 5 here, x raised to the power 5 minus 1. So that means the y dx, so it implies the y dx equals to 2 into bracket 5 x raised to the power what? 4. So which is equal to 2 times 5, that's what? 10. 10 x raised to the power 4. So that means derivative of 2x raised to the power 5 is equal to what? 10x raised to the power 4. So the second example is this. So if y is equal to 1 over 2x squared, 1 over 2x squared. So then what will be the y dx? So there are two things that you have to do from here. So look at this. This y can be written as this 1 over 2 times 1 over x squared, right? It will still be 1 over 2x squared. So then this should be equal to 1 over 2 x squared. Remember the rule of indices. Rule of indices that says that 1 over x raised to the power a equals to x raised to the power minus a. So the same thing with this 1 over x squared. So that means the same thing goes for this. So 1 over x squared is equal to what? X raised to the power minus 2. X raised to the power minus 2. So that means our y now is equal to 1 over 2 x raised to the power minus 2. So now this is just a constant that we separate. This is what we are differentiating. So that means this is equal to 1 over 2 into bracket x raised to the power minus 2. Bring minus 2 here. X raised to the power minus 2 minus 1. So that means we have 1 over 2 into bracket minus 2 x raised to the power minus 3. So that means we have 1 over 2. So this we have 2 here, we have 2 here, 2 cancel 2. So we have just minus 1. So that means we have minus 1 times 1, that's minus 1, minus x raised to the power minus 3. Minus x raised to the power minus, that's the derivative of 1 over 2x squared equals to minus x raised to the power minus 3. So that is that about the algebraic function. So let's move to differentiation of sum. Okay, so differentiation of sum is just means that when we have something like the sum of each term. So how are you going to differentiate it? So we know that if y is equals to u plus v, we say the y dx is equals to the u dx plus the v dx. So it implies if you have a function that is a sum of two terms, then the derivative of that function is you differentiate each term one by one. Differentiate this, differentiate this, differentiate this. That's what this means. If y is equals to u plus v, you use a function 3x, v also is a function. So then the derivative of that y is equals to the u dx, you differentiate u, and also you differentiate v. So that's how it works. So now look at the example. The first example that we have is 1 plus x squared. So if y is equals to 1 plus x squared, so then the y dx will be equal to, we're going to differentiate this one. So we're going to differentiate this one. So we'll differentiate this one. The derivative of 1 is what? 0. Because it's a constant, right? Derivative of x is equal to what? 2. You bring 2 here. X raised to the power 2 minus 1. You subtract 1 from here. So this implies that the y dx is equal to 0 plus 2x, 2 minus 1, that's what? 1. So that means the y dx is equal to what? 2x. That's that. So then we have, if y is equal to 2x plus 3, so then the y dx will be equal to, first we differentiate this, that is 2. So but from what we have here, 2 is just, we're going to differentiate ordinary x. So this ordinary x now is the same thing as x raised to the power 1. So that means you have x raised to power 1, abi? So to differentiate this, if x is the same as x raised to power 1, you break this 1 here times x raised to power 1 minus 1. Remember, you subtract 1. So plus, so we said derivative of plus, differentiate 3. Derivative of constant, 3 is a constant, is equals to what? 0. So then we have 1 times x raised to power 1 minus 1. 1 minus 1 is what? 0. Plus 0. So that means what we have there is this. So we have that the y dx is equals to x raised to power 0. Anything raised to power 0 is what? 1. So that means we have 2 into bracket 1 plus 0, which is equals to what? 2. So that's differentiation of what? Sum. So this is where we're going to stop in this particular video. So I'll see you tomorrow.